Excited I get to be here as the first presenter in this session. My name is Jeremy Scheff. I'm an indie video game developer, and all of my video games are PWAs that make pretty heavy use of client-side data storage. So that's why I'm here giving this talk today. I want to talk about both the current state of data storage as well as where things seem to be headed in the future. So let's just jump right into it. If we're talking about data storage today, we're mostly talking about IndexedDB. That's the main way we have to store a large amount of data client side. And there's some good things about IndexedDB. You get some high-level database features like indexes and transactions, very useful. There used to be a lot of criticism about certain things in IndexedDB, such as cross-browser support. That was an issue for a long time. Not so much anymore. The past few years, we have pretty good support in all the major browsers. There used to also be a lot of criticism about IndexedDB's API. It has this kind of, idiosyncratic event-based API because it was standardized before promises existed. But these days, there are pretty nice wrapper libraries like IDB and Dexy that lets you get a nice promise-based interface to IndexedDB. So some of those kind of common criticisms of the past no longer are huge issues for us as application developers, but there are still some limitations when we're using IndexedDB. And I'm going to touch on all these limitations that I have listed here at different points of my talk. But I kind of want to start by talking about this last one, complex queries. And so what I mean by complex queries are if you want to do the same types of things you do when you're working with a SQL database. If you want to do joins, you want to do aggregation, you want to have foreign keys, whatever SQL type stuff you can think of. For the most part, these are not supported out of the box in IndexedDB. You get, as I said on the previous slide, transactions, you get indexes. That's kind of about it. And so there was some talk about this back in the days when IndexedDB was being standardized. People were wondering, is this a high-level database? Is this a low-level database? What are we really building here? How are people going to use this? And one argument that people would make is that, well, yeah, it might be kind of low-level in the sense that we don't provide you all the features you get in a relational database, but you could imagine building a relational type database on top of IndexedDB and getting some of these, fancier types of queries in some layer that exists above IndexedDB. In practice, how has that played out over the past decade or so? You can find examples of people doing some clever things with indexes and cursors to make queries that you might not think IndexedDB could do out of the box. But for the most part, it's nothing approaching what you can do with a SQL database. And this is kind of a challenge if you're building a application that makes kind of heavy use of the types of features that you would want from a relational database. But within the past couple of years, there have been, I think, some very exciting developments that give us some idea about how things are going to look in the future. So there are these two libraries I have listed, AbsurdSQL and WA-SQLite. And what both of these libraries do is let you run actual real SQL queries on top of data stored in IndexedDB. So, that's, things are getting a little exciting here. When we think about that, that's kind of, what a lot of people wanted in the first place and what a lot of people have been, hoping we would get to the point of being able to do. And it seems like, we are getting there. So these libraries I mentioned, what are they doing to run SQL on IndexedDB data? Well, what both of these do is first compile SQLite to run in the web browser. And this in and of itself is not a new thing that, people have done that, for years. But in the past, that was working on an in-memory database. So you could load data into SQLite, you could query it, but then as soon as the user closed the browser tab, the data was gone. So what these projects are doing differently is they are hooking up the backend of SQLite to IndexedDB so that the data is being persisted the same as any data you write to IndexedDB. So this is really cool because you kind of have the best of both worlds. You have the ability to query the data in sophisticated ways like in SQLite, but you also get persistent data in your PWA. And you might think, well, how does that actually work in practice if you're running one database, SQLite, on top of another database, IndexedDB? That's not really normally the way that things are implemented. Like, is this going to be really cumbersome or slow or something? And actually, what has been found, and these graphs I took from this blog post I linked to from James Long, who's the author of the Absurd SQL Library, and he found that writing queries to query your data through SQLite on top of IndexedDB actually ran faster than hand-tuned queries accessing the IndexedDB API directly. So it's not necessarily true that doing something like this would result in bad performance. So it's kind of a pretty promising technologies, I think. Of course, there are some limitations or challenges here as well. So first, I think it's kind of fair to say that all of this stuff is kind of experimental at this stage. Like both of those libraries I mentioned are pretty much projects made by an individual developer. I'm not sure if they have much production uses at the moment. They both give you kind of a large bundle size because you have to ship a whole copy of SQLite with when you're using it. And actually, I noticed, I think just like yesterday or a couple of days ago, somebody had done something similar with Postgres, letting you run Postgres client side and storing the data in IndexedDB, very similar to what I was talking about with SQLite. And doing that with Postgres resulted in like a 30 megabytes bundle size. With SQLite, it's probably it's less than a megabyte. So maybe not the end of the world with SQLite, but still a concern. And then this third thing I have listed here, so on my first slide, one of the limitations or challenges with working with IndexedDB now is related to data persistence. And if you have something on top of IndexedDB that's storing data in IndexedDB, you still have the same concerns there. And I'm going to talk a little bit more about that now. So when I say persistence, what do I mean here? So what I really mean is, like, can you rely on your database? Like, if you write some data to the database, then sometime later you try to read the data back, is your data still there? And of course, as programmers, we know that there's no such thing as 100% guarantee. There's always some risk that something will go wrong. But you can still think about different situations, different technologies, like how likely is it that something will go wrong? What are the circumstances in which something may go wrong? What do I need to prepare for? What assumptions should I be making? So with IndexedDB and kind of PWAs in general, a lot of people see client-side data storage mostly as like a cache, like a temporary cache of whatever I'm also storing on the server. Even if you see it this way, it's still really important to consider, these data persistence issues, because you can imagine there's some client-side data the user has. Well, what if the data gets lost or corrupted before you're able to sync it to your server? Or what if the user expects some data to be available offline, like before they're getting onto a flight, and then somehow the client-side cache is lost or corrupted, and now that data is gone. That's not a great user experience. But there's also, as I'm showing on this slide, some use cases where, as a PWA developer, you might want the client-side data storage to be the primary data storage. And, that kind of hits close to home for me as a developer of free video games that store a lot of data client-side, because, that's kind of the use case I have. And just to give a little more detail of what I'm talking about here, so this is a screenshot from my most popular video game, which is called Basketball GM. And in here, you're managing a simulated basketball team. And it is a purely single player game. So you can simulate as long as you want. You can, simulate tens of years of simulated basketball, or hundreds of years, thousands of years. And you can still retain all of the data from your past exploits. And you can analyze it and view it and compare it. And as a free game, I don't really want to be storing thousands of seasons of data for my users in the cloud. And that's kind of both for financial and performance reasons. It's a lot better to have that data client side. And so currently I have all that data sitting in IndexedDB. And for the most part, it works. You can keep throwing data in there, and it keeps running. But you do run into some situations where you have inadvertent data loss. So how can this happen with IndexedDB today? So if you're using a public device like in a library, or if you're using like a private browser tab, there's not really much that you can do about that as a developer if that's what your user is doing. But I think that's okay. I think users kind of understand what they're getting into if they do something like that. But these last 2 points here are a little more interesting, I think, because these are more like unique problems that we as PWA developers face that a lot of native developers might not have to deal with. Sorry, messed up my slides. Yeah. So yeah, that middle one there, if the user manually clears their browser data, so that could happen in like a few different ways. It could be like the user is clearing their data within their browser settings. Maybe some website's not working well and they're trying to do that to fix it. Maybe they're trying to clear up some space. They could also be using some kind of like external junk clearing program on their computer, and they might not realize exactly what it's doing. For the most part, an end user is not really going to understand the distinction between my data is in a client-side cache, my data is client-side only, my data is on the server, my data is on a file on my hard drive, my data is stored in my browser profile. They're not going to have a great idea of that. They might not know what cookies and other site data means in the browser settings, and they could wind up accidentally deleting data without realizing it. And then this last point I have here, eviction. So that's what happens if your browser notices your disk space is running low. It might say, hey, if I have some kind of transient, non-essential cache data, maybe I can just delete that data and free up the disk space. And the user's not going to run out of hard drive space, because it's really bad to run out of hard drive space. And this is mostly an issue on mobile. And personally, given what I said about how my PWAs work on the previous slide, I do get complaints about both of these issues, mostly from people on using it on mobile. But these are kind of real problems, and people can accidentally lose their data and be confused about what is going on. So what can we do about this? So one thing that's out there is this persistent storage API, and it's pretty simple. Like, there's just one line of code on this slide. You call that one function, it returns true or false. And if it returns true, that means you have successfully marked your data as persistent. This means that it will not be evicted if the device is running low on disk space. So that sounds pretty promising. And Safari recently added support for this. It's supported in all the major browsers now. However, in practice, I've found a lot of challenges dealing with this. So one is that, at least in Chrome, it's not like a normal permission system. So by that I mean, like when I had to share my my screen and my microphone and my camera today, Chrome pops up a little notification like, do you want to share this with this website? When you use this persistent storage API, it does not pop up a notification and ask. What it does is use some heuristic behind the scenes to figure out, do I want to accept this request or not? And if it says yes, then it's great, because you get persistent storage and you didn't have to bug the user about it. But if it says no, it's a little tricky, because your hands are kind of tied then. Even if you tell your user, give me this permission, enable this thing, it might still not work. So that can be kind of confusing if you get into a situation where the user wants to enable this feature because they want their data to be persistent, and they can't figure out how to do it because the browser won't let them. Another challenge here is that this only works with eviction. So this will not do anything about clearing your browser data in any way. So that can still happen even if persistent storage is enabled. So it's like, it's called persistent, and you may call it persistent, when you're showing some notification to the user, but it still may be deleted if the cache data gets deleted. And then this other issue listed here is that it may not even completely help with eviction. I'm a little fuzzy on this, but I've just gotten like, a number of reports from users that will say something like, I enabled the persistent storage in my settings, and then the next day I went back and checked, and somehow it became disabled, and I don't know what happened. I didn't do it. Or they'll say I enabled persistent storage, and somehow, the data still got evicted, and I don't know what happened. And personally, I'm not exactly sure what's happening in these situations, but in practice, I think the big picture is that this doesn't really solve all of the problems that apps like mine are having, and that my users are having. So what else is out there? So there's this thing called the Origin Private File System, or OPFS. This is a pretty new technology, and what this lets you do is write your JavaScript code that interacts with files, pretty similar to interacting with files in other programming languages. So it's designed for kind of like high performance reading and writing of data from files. Now the catch is that these are not real files. They are, they appear as real files when you're working with them on your website, but no other websites can access them, and even the user can't really access them outside of their website. Like they don't generally appear, in some standard place on the user's file system. They're really just for your website, for your domain. And that's what the Origin Private part of Origin Private File System means. And overall, I think this is really exciting technology, especially if you think in terms of what I was saying earlier about these SQLite on top of IndexedDB libraries, because, this type of backend would be a lot more similar to how SQLite and other databases work in native apps. So potentially, you could imagine it working a lot more smoothly, a lot more easily, and a lot faster. And while I was thinking about this presentation and what exactly I want to talk about here, I noticed that the Chrome development team made this announcement that they were going to start working on a kind of official library for running SQLite on top of the OPFS in conjunction with the SQLite developers. And I think that's also pretty exciting news, because yeah, I mean, I think then you get a better chance for bringing publicity to this stuff and getting like a well-supported library. And I'm not sure what progress has been made other than announcing that this project is going to happen, but I'm very excited to see how that plays out. But then so I also like I was talking a lot about the persistence issues in IndexedDB previously. So what's going to happen with persistence in the OPFS? So one thing I've noticed in the spec is that it says clearing browsing data will not affect these files in any way. So that's pretty promising, because like I was saying about the persistent storage API, how that only affects eviction. It doesn't affect, somehow the cache data is cleared. This is addressing that other problem. So now we potentially have solutions targeted at, both sides of this, inadvertent data loss problem. However, and this is kind of just speculation on my part, but I'm still like a little bit, nervous. Like, is eviction still going to be an issue? What's exactly going to happen there? Because you can imagine, you have a website that stores a ton of data in the OPFS. The user doesn't visit that website again for a really long time, and then the browser realizes disk space is running low. I feel like it's going to be tempting for it to delete these files or something, because these aren't real files. These are these kind of pseudo fake files, private only to this website. But yeah, like I said, that's kind of speculation on my part. I am hopeful that through these technologies, we are ultimately going to be able to operate on data in our PWAs, client-side data specifically, with the same level of confidence and sophistication that we can in native apps. And so with that, I just want to highlight some of the questions that are raised from this talk that I think are going to govern how this stuff plays out in the future. So yeah, so when are all browsers going to have OPFS support? Because, as PWA developers, we generally want to support all the modern browsers. And I'm mostly talking about Firefox here. But yeah, I think we're going to need to see support in all web browsers before this becomes like a real mainstream thing. I'm very excited to see what Chrome and SQLite developers come up with in terms of a SQLite on OPFS library. I am somewhat anxious about, what is going to happen in terms of persistence. Are we really going to be able to solve these issues and build these kind of sophisticated client-side data PWAs? And, is anything ever going to be able to be done about bundle size, or are we going to have to be shipping an entire database engine with any PWA that we want to operate on client-side data in a relational manner? And if so, it's not the end of the world necessarily. SQLite is, fairly small as these things go, but yeah, it'll be interesting to see how that plays out. And uh, with that, I am concluding my talk, and please reach out to me if you have any questions or if you want to talk more about any of these things. I am on the PWA Summit Discord, and I'll be switching over there to see if anybody's saying anything after this talk. And also, if you enjoy nerdy sports video games, check out one of my PWA video games, but please only after you have already listened to the rest of the talks in this session. So yeah, thank you for listening, and yeah, that's all I have. Bye.